Hi, in this video, we're gonna have questions, more specifically multiple choice on topics of 2.3. So if you remember, 2.3 is about all the things related to carbohydrates as well as lipids. So these questions are gonna be related to it. So we're gonna tackle them. We're gonna look at some common questions that come out. We're also gonna look and try to translate some of the words and also look at some of the drawings for these two. So I would advise first that make sure you really know 2.3 before you can go through these questions, but let's tackle some of them, just for you to get exposed to what kind of questions can come for this topic. So here's the first one. It says, which molecule, okay, is a polysaccharide? Now, from this thing, you already know that the word saccharide means sugar, and poly means many. So it has to be something that has many sugar put together. Now, the IB does that. You see, you can see that the words are very close to each other. Glucagon, glucose, glycerol, glycogen. So it kind of gets a little bit of worry, right? But if you actually know this information by studying 2.3, you would know that first, we have glucagon. Now, glucagon is basically our hormone, okay? And it's a hormone, it's a protein hormone that it's regulating sugar. Glucose, in this case, this is just one unit of sugar, and here's asking for many. Then glycerol, there's rol in the end, which is basically alcohol. In this case, it's not sugar, it's more like a fat. And then you have glycogen. Now, glycogen, if you did study, glycogen is basically a storage of bunch of glucose attached to another glucose attached to another glucose, which, wait the way, that is many sugars bound together. So the answer for this one, it is D. So be careful between glycogen and glucagon. So glucagon here is a hormone, okay, and glycogen is a storage of sugar. So be careful not to fall in that trap. The only way you will not fall in this trap is memorization, writing down many times. So going for the next question, it says here olive oil, and you can see that olive oil means what? Fat. Okay. May reduce the risk of coronary heart disease. So basically, it's a good fat. So olive oil is a good fat, right? Now, what is or are the compound responsible for the healthy benefits of olive oil? So basically, when they say compounds, they're trying to say, what is this fat made of, this good fat? That's the question. So here they give you three options. It says the cis unsaturated fatty acids. When I say cis means something like this. You have a hydrogen connected to a carbon, attached to another carbon, which is connected to another hydrogen. And then you could have here CH2, and then you can have here CH2OH, OH. That's what cis means. Cis, that if you put a mirror right here in the middle, right? And if you look at each other this way and you look at each other, they look the same. That means the hydrogens are in the same side on the same location. Now, if it was trans, it would have mean that the hydrogen will be in this side, while the other hydrogen, oops, put this here, would have been the opposite. This means trans this way, while this means cis. So if it's cis, that means it's good. If it's trans, which is a bad one, okay, that is definitely not a good healthy benefit. So this will be the bad fat, the trans fat. So cis unsaturated, unsaturated. Now, what does unsaturated means? It means that the chains of that carbons of going on like this, there's a double bond. And whenever you have a double bond in that huge chain of carbons with like hydrogens all attached, the more double bonds you have, the more healthy you are. And the double bond means you're not saturated, so it's unsaturated. But again, if I look at the bottom one, it says trans unsaturated, it will be this one, which is a bad fat, so it cannot be two. Now the cis, it's possible. It has a double bond, so it's unsaturated and the hydrogen next to each other. So this is possible. The second one is not. The third, saturated fatty acids. We know that anything that is saturated, it is bad fat. Now, here is a little recap, so maybe you can memorize this, but if you have a single bond, that's bad. If you have double, triple, that is good, because one single one, that is saturated. These guys are actually unsaturated, and these are the good ones. Now, between those, the cis is even the best one, and if you try to do trans out of it, it is a very bad one. So looking at this, saturated fat is not good, right? It's that one that only has a single bond, it has double bond, no bond, double bond, so it's bad. So we can see that one, it was the only one good one. So you have an answer right here. This is the only one because it cannot be one or two and three and the rest of it. So the right answer is A. Now this is common knowledge because if you did study 2.3, you will remember, once again, that anything that is saturated, it is a bad fat. Anything that is unsaturated, it is a good fat. So in this case, olive oil, salmon, omega-3, saturated is more like a junk, like pizza, cupcakes, and stuff like that. And then when you have a double bond, if the hydrogens are on the same side, right, then that's a cis, which is a good thing. But if the hydrogen bonds, you're connected to another one, are on the opposite side, that's trans, and trans is a bad one. So trans is a manipulated in the lab, which is bad, but cis is a good one. So remember, cis is always good, as this is always an A. So let's go for the next question. A polymer. Polymer means a large molecule, right? And that means you have to remember this, that the word poly means many units, right? Because the word poly is equal to the word many. And mer means unit. So it's many units of what? Of alpha D glucose. So that means we have a bunch of glucose like this. These circles are glucose, and it's just going like this. Now, it says that it's found in the plants. It has mostly 1 to 4 linkage and some 1 to 6 linkage. Now, this is saying that, for example, if I had to draw this in more detail, okay, if I had a sugar right here, right, and here's oxygen, you have carbon 1, 2, 3, 4, 5, and then there's a 6 here. Now, this guy is going to be attached to an oxygen when it's attached again to another molecule here. This is, again, these molecules I'm drawing here are sugar. And here you have the oxygen. So this is 1, 2, 3, 4, 5, and then a 6. And this is attached to an oxygen, which is attached again to another sugar, right? So I'm building the entire large sugar here. Carbon number 2, number 3, number 4. So if we look at the links, the link here is a carbon number 1 attached to carbon number 4, right? This means it's a 1,4 linkage as I shown here. Now, it's saying that not only does it 1,4, but it has 1 with 6. What does that mean? That means that they have another sugar here going in this direction, right? And it's basically saying that it's the link of 1 through 6. Now, 1 through 6, that means carbon number 1 here would have been connecting with 6. So it would look like there's the 1 attaching to 6 here. Now, what is this causing? This is causing a branch. The branch is happening here. And you can probably have another 6 here, and you can have another sugar coming out like this, and it's bound to a 1, and another branch that keeps going here, and it keeps going. So it's not just linear like that. It's linear with branches going on. So then you have to remember, what is it that has both the 1,4 linkage and the 1,6 linkage? That it's not just linear, but it's branched. So you have to go back and study and look at all the different options of polymers for glucose. So taking away this drawing, now we look at the options that we have here. First one is glycogen. Glycogen, okay, in this case, it has a bunch of sugar, right? And it just bounds a bunch of sugar again, and it keeps binding sugar again. And it just keeps going, okay? Now, even though he's doing this, he only has the 1 to the 4 linkage. Cellulose does the same thing. It only has this, but you have the alternation of that 6 carbon here, the 6 carbon here, and then the 6 carbon here, and then the 6 carbon down. This one, they're all in the same place, right? Oops, it's on this side here. 1 here, 1 here, 1 here. So also it's a linear. So this is linear, and this is linear. So cannot be glycogen, cannot be cellulose. Now you might ask me, how do I know this? Well, that is in the chapter. You can go always back to the videos and I show you the structures them. Then you have amylose and amylopectin. Amylose is just looking like glycogen, and again, it's 1 through 4. It's linear, just like this one right here. Now, amylopectin is the one that has basically the chains that I showed you. You had the drawings like this, and then you had it connected this way too. So amylopectin is the one that has both 1 through 4 and 1 through 6. Now, I know the drawings here is not accurate, but the only way you would have known this is if you actually go to the video and you study the difference between amylose and amylopectin. These are two types of starch, and they're made of a bunch of glucose, but one only has the 1,4 linkage, which in this case is the amylose. And the one that has both of them, 1,4 as well as 1,6, that's amylopectin. I know this from the studies. So if you know very well all the 4 of them, glycogen structure, the cellulose, amylose, then you would have easily spot this in the question. So the answer for this one is D. Now let's go to this question. Now, just by looking at this, when you see a large chain of carbons with hydrogen, you can automatically assume that this is going to be fat. And you can see a tiny little glycerol going on here, right? So this is a glycerol, which is part of the fat, right? And this is basically fatty acid. So obviously, and it says here palmitic acid, it's a fat. Now, the question is saying what type of fatty acid is the palmitic acid? Now, saying now what type, when we talk about type of fatty acids, now is asking, is it monosaturated, unsaturated, any of this? So when it does this, the first thing that you will look at the bonds. See if all the bonds here are single. And I can see that all of them are single. There's no double bonds. If there's no double bonds, that means it cannot be mono, unsaturated, or unsaturated, because the word unsaturated here means this has a 1 double bond. Poly means you can have 2, 3, 4, 5, whatever many bonds. Saturated here, this necessarily means that there is a sol on a single bond, so C most likely to be. Now, trans fatty acids, again, this has to do with across hydrogen with the double bonds, right? Oops, hydrogen here, carbon. So it does have a double bond, so it cannot be. So it's not trans fat. So the only answer you can have here is C, because saturated means you have all single bonds, and that means you have been saturated with all the hydrogen on the sides, all the hydrogens have in place. You're completely saturated with hydrogens, and that's what saturated means. So the right answer is C. Moving on to the next question. Now, what type of molecule is shown in this again? Now, whenever you see, and this is already telling you, if you see something like this, zigzag like that, automatically know that it's fat. I'm telling you from now, you see these lines, like I'm showing here, all you see lines long like this, it's automatically fat. Why? Because what does these lines basically mean? These are basically a bunch of carbons chains with hydrogen. Here, hydrogen and hydrogen. Instead of drawing all of this, they just do a line like that, in which is a carbon, a carbon, a carbon, a carbon, and then you can put the hydrogens inside. But just to minimize so much drawing, they just make lines, so it's still a fat. Now it's asking what type is it. Now, if you notice that right here, there is, so if I do this, that means it's a single bond all the time. If I do this, and then suddenly I do this, and I put a line like this, and I continue, that line there, it means that it was a double bond. So that means it's made of this. So because there's a double bond, it cannot be saturated. It must be unsaturated. So the first one is out of there, and now we have 3 options. Now the next 3 options, it says cis. Oh, this one says saturated, so it's definitely not this one too. So we only have B and D to look at. Between B and D, that's the next question that we're gonna look, things that we're gonna look. So we already figured out that it's unsaturated, but is it cis or is it trans? If it's cis, that means the hydrogens should be on the same side. If it was trans, then the hydrogen should have been on the bottom part, but it was not. So this is a cis, so the answer is obviously B, because the 2 hydrogens are on the same on the top. Now moving to the next question. We have here a diagram that is showing two types of polysaccharides. And you see how these guys are like this, and then it has branches coming out. It's not like the fat that I just told you there was a zigzag. So remember, the zigzag is more for the fat. And then when you have these little twirls around here, these type of designs here, these are more like sugar. So these are two types of molecules, like of sugar molecules, which it has like a lot of sugar in there. But one is spiral and the other one is more like a branch is going on. So they're asking for their names. Again, this, it has nothing, there's no trick. It's all about you actually studying the video that I did on 2.3 and memorizing their structures. Now we know that everything that is spirally in this case will be amylose. How do I know it's amylose? Because the only way is to know the amylose structure. And amylose is linear, but it's not just a line like this, it's actually like this. That's amylose. So do we have amylose here? Yes, we have amylose here and amylose here. So it can only be between A and D. Now amylase, the word A is here, you can already reject. Why? Because A means an enzyme. So enzyme is not made of sugar. Enzymes are made of proteins, right? Anything that ends with A's is an enzyme, as I was writing here, and it's a protein. And this, we're talking about sugar, which is glucose. So it cannot be any of this. We can reject that. Now, we're looking between glycogen and amylose, and amylopectin, right? Now, amylose, we already figured out is that straight line. Now we're trying to figure out what could it possibly be, right? Is it amylopectin or is it glycogen? Now, amylopectin, if you remember from amylose, amylopectin would closely look like amylose, but then it would have branches like this. So it's just a branch pumping out of a linear. So it's a linear with extra branches just like this. This one here, it doesn't have just branches coming out. You have branches and then branches after branches. You can see branches after branches. So this is a branch and then it branches again. So when you have those extra branches popping out, that is actually glycogen. It's the storage of sugar. So clearly repeating again, just to make sure, what's the difference between amylopectin and glycogen? Is the amylopectin is just a straight line and then you see branches coming out straight like that. Glycogen, on the other hand, it is not. You branch here and then you branch again and then you branch again and then you go up here, then you branch again, then you branch again, and then this one can branch again and then branch. So there's many branches after branches, and that's what glycogen looks like. So and the answer here will be A, because X right here is glycogen and Y is amylose. Next one, which of the molecules shown would be the most suitable for long-term energy storage in humans? Now, we know that when it comes to carbs give you quick energy, which that means I need the energy now. So this case would have been a short one. And the fats, these are the ones that give you in a longer place. So these ones are very long. So they're looking for you, asking you to figure out which one of these molecules is the fat. Then this is where students get the trick. Now, we're looking at this and we know that A is not it because you can see that it's a sugar, so it's canceled. And D, it looks like you see, if you see the nitrogens here, right? These nitrogens, that means it's amino acids. So it's not these two because it has to be fat. So looking at here, we already know that these two are out. Remember, protein amino acids has nitrogens, and then the hexagonal pictures are glucose. Now, I kept telling you that when there is the zigzag right here, that means it's fat, right? Now, you have on both. You have it on this one as well as this one, so then like you get stuck. Shoot, how will I know if it's B or C, right? Let me erase this so make it more clear here. Why B or C? Because for me, if they have those zigzags, then obviously they would have been considered as fat. True, this is where IB can be a pain in the ass. Because if you really look a little bit more closer, this one has just, okay, let me put in highlight here. You see, this is the first fatty acid chain. This is the second one, right? Now, there is no third one here, but this one has the first one, the second one, and the third. So they're asking which one can give you the long term. It's the one that has more fat, the one that can give you more time energy. Between these two, the first B here, it only has 2 fatty acids. And this one has 3 fatty acids. So you got to think, the more fat, the more you have long term. So is it 2 or 3 fatty acids that gives you more energy? Obviously 3, right? More fat. So C would have been the answer. And you can see here that this part here is literally this. But this one has lost the first fatty acid. This one has all the 3 complete. So the more fatty acids you have, the more long-term energy you will get. So again, both of them are fat. It's just that one has more fat than the other. And that's how IB will do. So they simply play these tricks on you. In this case, C would be the right answer. Now we have here a part of the end of the chapter, which is about the BMI and figure out the nomograms when it comes to people's BMI using their heights and their weights. So in one side of this, we have the weight, right? You can have it in pounds or in kilograms, and you have the heights, centimeters or inch. And right in the middle, you have the body mass index, right? That you can go from 10 all the way to 70, but people never get to that level. So the range usually is around here between the 17, 18, all the way to the 40s. So in one side, you have the woman, right? And the different levels. We have obese, overweight, acceptable. And in the other side, you have the man, which is obese, overweight, acceptable. Now, when they put this in the graph for you, like on the test, you're like, how do I analyze this? How do I do this? You have to have a ruler with you. Make sure you have this ruler with you in the test. Always bring a ruler in the test with you because the ruler will help you with so many things. So you're going to take this ruler. Now it says here the woman has a height of 165 centimeters. So I look at the height and look for 165 and I'm going to highlight instead of doing this. Let's use another color here. 165. Oh, it's right here. So that's her height. So if the woman has a height of this, now the question says, what is the minimum mass? That means the smallest weight she can have in which she will still be considered, she will be considered overweight. That means there she can have up to this minimum mass and that, hold on, what is the minimum mass at which a woman of a height would be considered overweight? So that means at a certain point, what is the mass that puts her into a consideration of being overweight? So this is the case where you get the ruler, and the ruler usually you will land here, a ruler, and then you would just line up like this and touch the weight like this. And when you put the ruler like this, it will tell you if the ruler will cross. If you see the ruler is crossing on the B's, it will be this. Or let me go back here. What if I do the ruler like this? And then I cross like this, the ruler with the 65. You can see that the ruler is touching what? It's touching the overweight. And then I can take the ruler again. And maybe I do the ruler straight like this. And I go like this. Then you can see that it's touching the acceptable, right? So you're playing with the ruler. You can put the ruler like this. You can put the ruler like that. Or you can put the ruler like this. And where the ruler touch on these stages, it will tell you if the person is obese or not. So going back here, let me clear all that. So they want to see what is the minimum weight, and that means somewhere here, the minimum weight that will keep them in the overweight section, right? Because that they want the overweight. So that means they want somewhere in this area because it has to hit this. The ruler has to hit this. So if I had the ruler, of course this is shown here on the paper test, the ruler will have to be something like this, and you'll be hitting somewhere here, the ruler. So this is where you're definitely going to be hitting the overweight section. So if I look this more closely in this area right here, okay, it's completely dirty here. So if I open up and see it in this area here, so then you're going to be like, okay, shoot, they are all close. It's 60, 64, 67, 72. This is in the computer, but when you get there, you will know that it will be touching somewhere here, which that means the answer would have been 67. Now, of course, I'm doing this on a computer, so it's not to scale the screenshot of this picture. This picture will be a little bit more bigger, but when you actually put the ruler and your ruler is crossing the overweight, it will hit somewhere on the 67 right here. And obviously that will be uneasy for you to target, just for you to figure out, okay? And that will be the minimal mass as long as it's touching the overweight. So the answer would have been B. But this is just to show you how to use the nomograms. It's just using the rulers and you touching. Another way here, let's say if I say that the person has a weight of 110 and has a height of, let's say, 175, okay? How would you know what they are? It will be simple. So you will take the ruler and you will first find where is the height. The height 175 is right here. So the ruler is here, and the weight is 110, is right here. So you take a ruler and you line up like this. And in this case, you will figure out if the ruler is hitting what. So basically it is obese for the woman, but for the man, it most likely would have been overweight. So this is how you figure out these stuff. But here's another nonogram that is also used, but this one is actually used for children. So basically they're saying here that there is a 9-year-old, right? He's 9 years old. So in the chart, you look for the age, he's right here. The boy has a height of 120 centimeters. So it's not on the chart. You can see here is only about BMI. And he has a weight of 28 kilograms. What weight category is he in according to the BMI? Now the categories are saying here obese, overweight, healthy weight, underweight. And it's BMI. So then you're like, wait, they gave me the height, right? And they gave me the weight, but they didn't give me the BMI. Of course they didn't give you the BMI because the BMI you have to calculate. So the BMI here is actually the mass over the height squared. So let me erase this part here. And let me write again the word. BMI is basically the weight in kilograms over the height, which is in centimeters, squared. So that means it will be 28.8 kilograms divided by, and then here, see, it's 120 centimeters. You got to put 2 meters, right? Because it has to be meters. So I do not put centimeters. This is where the mistake of students, and let me highlight this again. You see, it was in centimeters here because it was in centimeters, but in the real equation, it has to be in meters. So it's in meters squared. So be careful in not making that mistake. So you have the kilograms, right? The kilograms right here. You have this, basically the meters and the square. Now that's the BMI. So of course you will have to figure out how much that is. You basically take the calculator and you do the calculation. So if it's paper 1, you cannot use the calculator. So in this case, you will have to basically multiply 1.1 and 1.2 times 1.1, get its number, and divide that by the 28.8 by that number. And once you do that, you basically will see that it will fall around the overweight. So that means it will line up somewhere here because it will give you like a 23 something. So the 23, which is here, and the 9, actually no, this will give you, if I should have got a calculator. So this is basically, it will be giving you overweight because that means if it's 9 and it's going to give me overweight, so that means he's going to be hitting somewhere here between the 28 and 18. So this is where the answer came. It came out to be overweight. Now this is of course because I'm not calculating at this point, but if I had to do this, I would do the whole thing, which that means if I don't have the calculator, I will go 1.2 times 1.2, do the whole thing. This is 4, this is 2, this is 2, and this is 1, so that's 144. That's 144, so it's 28.4 divided by 144. And again, I will put it 0 this way. I can put it like that, and I can find 284. What would it give me? And it will give me the answer. So you can calculate through your head, but most of the time IB will not do this to you. They will definitely give you this when there's a calculator. But if they don't, they will make it very obvious to you and what's the numbers will be. This one was kind of a bit of a pain in the ass, I can say that. But the first thing that I want you to get out of this is the BMI equation. And I want to be very clear again about it. when I'm talking about the BMI equation, it's very important you look at the units, right? So BMI, once again, is in kilograms over meters per squared, okay, not centimeters. As right here you saw, they gave you in centimeters. Make sure you actually putting in meters. You do that and you're not going to fall in the trap of IB. So moving on to the next one, we have here what fatty acid would occur in a trans fat. If you remember the trans fat, first it's a double bond between the carbons, and that means one hydrogen is on one opposite of each other. So you have to look at them for double bonds. The first one, you can see that all of it is single bond, single bond, single bond, single bond. So A is not it. Then you look at B, and B, you actually did find a double bond. So that after you find the double bond, the next thing you look is the hydrogens. Oh, and they're on the same side, so that's a cis. And since it's a cis, that's not a trans, so B is off. Then here, you have a double bond here, and you have a double bond, and they both are on the same side, so it's a cis, so it's out of it. Then you have this one where you do have a bond, but look, the hydrogens are opposite sides. And that's when you know that this is D. This is actually the trans fat. So this is how you do when you're looking for trans fat. Look for a double bond, and then make sure that you're looking for the hydrogens on the opposite side of each other, and that's how you know it's a trans fat. The next question here. We have the table that shows the mass of different types of fat in some food, right? So there's different types of fats and their masses. So we have palm oil, canola oil, sunflower oil, and partially hydrogenated oil. This says there's 50 on the first, 70 on the second, 10, and 30. This is how much saturated fat it is. Then the polyunsaturated fat for each one, the amount of monounsaturated fats. Now remember that these two are the good fat, right? And this is the bad one. And then another bad one is trans fat, which is the worst one, okay? Now, we just looking at them and we can see what are the good, the bad, what's going on. Now, let's look at what the question is asking. It says, which oil here will be the least recommended for inclusion in a human diet? That means if we're saying least recommended, that means we're trying to say what is the worst oil in this chart? What is the bad one? The first way to look at this is to find the one that has the most bad stuff. So in this thing, we find that this is the bad and this is the bad, right? In the list, okay, we're going to see, okay, this has bad, but 0 here. So are these two, 0. So the chances are they are less likely because they're just one type of bad. But this one, it has all of it, right? It has the bad saturated one and he has the trans, so he has both of them. So this is the only one that has both. So obviously the answer here will be the partially hydrogenated soybean. D would have been the right answer for this, simply because it has both of the bads, while the other ones only have one type of bad and not the second. So in this question, how would you be answered? This you can only answer because I knew that if you're saturated, you're bad. Trans fat is bad. I knew from previous studies that saturated and trans fat are the bad ones, and that anything that is unsaturated is a good one. So anything that says unsaturated, like polyunsaturated, unsaturated, these are the good ones. That's why it was so easy for me to answer this question. Moving on. Here says, what distinguishes cellulose from glycogen and starch? Now, we know that cellulose is something that is found in plants, right? But we also know that the three of them, cellulose, glycogen, and starch, they're all made of chain of glucose plus glucose plus glucose, and it keeps going. So the three of them are made of a huge chain of glucose. Now, we have A. A here says that only cellulose is found in plants. Wait, is that the only thing? That is not true, because guess what? Starch is also found in plants. Okay? So it cannot be A, because both cellulose and starch can be found in plants. Second, only cellulose is made up of glucose monomers. That's not true. Why? I just told you. The three of them are made of a bunch of glucose, so it definitely cannot be B. Cellulose is far more branched than starch and glycogen. That is not true. They are made of just a chain of glucose, but the glucose is flipped. So it couldn't be this one at all, too. So the only thing left here is the cellulose has a structural role, whereas the starch and glycogen function in energy storage. Now, cellulose is a structural. Why? Because it makes the cell wall of the plant, and glycogen starch has a function. Why? Because if you remember, glycogen is a storage of glucose for the muscles, right? And starch is a storage energy for who? For the plants. So plants use starch as storage, and humans, animals, use glycogen as a storage. And it's storage for what? For energy. So D is the right answer. And this is awareness of before. So then we have to the next question here. And this one goes back to BMI. Okay, and you can see it's another graph here. So it's showing now in this type of BMI, it has the height and the mass. Okay, and then it has here the ranges: overweight, obese, normal stuff. Now it says, based on information provided, which individual is the most at risk of disease associated with accumulation of excess body fat? So we have to find here and see which one of these four individuals, which one of these guys are likely to have disease because they have a lot of fat. That means what I have to do is I have to calculate their BMI, which is, again, is the kilograms divided by the meters squared. That means their height. So what I have to do? Well, for each one of them, I will have to do the BMI for it, which is 96. And again, the good news is this is already meters, so you don't have to convert. 1.95 squared. I will have to do for the B, I will have to do the BMI 60 divided by 1.55 squared. I will have to do for C the BMI for it, which is 75 divided by 1.50 squared. And the last one, which the BMI is 80 divided by 1.75 squared. So these will have to do the calculations, which again, I be being a pain because you cannot use a calculator. So you have to calculate this in the paper and find the BMI for all of this. And when you do the calculation, it came out that C was the answer. Why? Because the C actually had the highest love number, which it was around the area of 30 or more. Now, you can use this calculation or make your life much of a trick. And what would the trick be is, because the students will go freaking out in this, just like I showed you right here. But then there's something very straightforward. You don't even need a calculator. And some people pick up from the first. I see people wasting their time doing this. And I'm like, yeah, let me just show you what it looked like. You just wasted your time. Because the truth is, this is what happens. You go here, the mass is 95. Okay, the mass is 95, so it's somewhere here, and the height is 195. 195, so it's about here. So I go the line like this, and I go a line like that, and his normal range. So, see? Canceled. It's normal. That would have been fast instead of seeing the kids doing the whole calculation here. But many kids I have seen going through this, and I just acted like you guys, that some of you guys will start doing this. Do not. Look at the graph. Second one is right here, which is 60 and 155. That means 155. Oh, so it probably is around here. So they're hitting right here. So they're in the range of normal range to overweight. Now, overweight is not excessive body fat for disease. It's just you're overweight. It doesn't mean you're still going through a bad situation. So B, you're still okay, but I would say be careful. Let's look at the other ones and see if they're worse. This one is a 75 and 150. So 150 in this line with the 75, they hit what? They hit the obese. So obese here, that looks like the C answer, right? Because again, that hits obese, which obese means you're really fat, and that means you're having disease. But don't just go on this. Now, we know that between B and C, C is worse, right? Because it's obese, it's not overweight. But you have to do the last one, which is 80. You have 80 here, and you have 170, so it's right here. Okay, it's overweight. So overweight is nothing compared to obese. So between overweight and obese is the worst, so that's more likely to have a disease. So a lot of kids, I have seen them do that, where they just stay calculating all these BMIs and doing from their heads because there's no calculator. It can be a pain and put people to go through this whole process of suffering, but there's always a trick. And the trick was simply just put them in the graph. That's literally it. I was finding their weights, finding their heights, line them up, and bam, finding their height, matching with the weight, and bam, that's how you find them in the graph. This is how you find if they are obese, overweight. It is very straightforward without the need of the calculator. So remember, IB will not be such a pain to a point that you have these big calculations. If you find yourself making this big calculation, that means you are not using the graph. Make sure to use the graph, the X and the Y, because it will be a faster way to calculate the BMI. So once again, the answer is C. And that's pretty much all the type of questions that get yourself exposed to 2.3. Hope that gave you a little bit of an insight and helped you out. Thank you.